Hello, how are y'all doing today? My name is Bernie Thompson, and today we're going to take a look at this 2000 Ford Crown Victoria that has an engine misfire. The first thing that we want to do is confirm that the engine is missing. So let's go ahead and start this vehicle up. Okay, I can definitely feel that I have a misfire and it's present. So that means that we can go ahead and run some tests. So let's go ahead and hook up an oscilloscope to this to check it out. So the first thing we want to do is we want to take the oscilloscope and we want to hook up the oscilloscope to the engine. Now what I'm interested in doing is running a relative compression test just to make sure that I don't have a compression deficiency, and that's where my misfire is coming from. So this is a real easy test to run. What we want to do is we want to take the number 1 or the channel 1 and connect it to the positive. We want to check the ground and we want to connect it to the ground of the battery. Then channel 2, we want to connect to the coil. When you look at the coils, you're going to see that I have a red green, a red, and a red white. We have a white brown with a red. So that means the red is my power feed to these coils. So I want to get into the control wire. That's going to be the other color wire, which is this green wire. The very next thing we want to do is we want to come into the scope and we want to look at meter. Now when I'm not connected, the red light is on. That shows me that that lead does not have a connection to the vehicle. But here on channel 2 and channel 1, I've got a good connection. That means that we're ready to run the test. So we want to come over to the tool tab, and now we want to open up the compression tab. We need to set this test up. So the first thing that we want to do is we need to find the firing order, which is 1372. So we've got the firing order set. Now, we're on cylinder 1 trigger, but we could use any of the cylinders, but we'll use 1. Now is what we want to do is we're going to go ahead and start the test, and what we're going to do is we're going to go ahead and crank the car over. In order to run this test, hold the throttle wide open. That will clear flood mode, and then do a long crank. Now that we've gotten the data and we have a long crank, we want to look at that data to see what we've got. Now we can see here that we've got our firing order. Now we've got 2 that's a little bit less, but notice none of them are really colored, and this is the raw data up here. I don't see anything that's really wrong with that, and I can see each cylinder is firing. So right now I don't think I have any type of problem with compression. So now I need to know what cylinder is missing to get to the next step. So we're going to go to the CKP misfire. Now we need to do the same setup here as we did before. So we've got the right firing order selected. We're on cylinder 1 because we just came off of that. So we're okay there. So now is what we're going to need to do is we need to take the number 1 or channel 1 and we need to connect this with a back probe to the crank sensor. Let's go ahead and do that. Now that we've connected to the crank sensor, go back to the meter. We can see that we're connected with this, and we can see that we have a 1.5 volts. That's the bias voltage on the crank. So we're going to be able to run this test. We are connected. Go ahead and just start the test. And then what we want to do is we want to go ahead and just start the car up. We're going to allow the car to obtain idle from a start, and I could feel it missing at this point. So this should be a good test. So what we're going to do now, we've got an engine that's missing. We're going to go ahead and we're going to shut it off. The system is now going to analyze the data, and it's going to give us an idea of which cylinder or cylinders are missing, because we're really not sure yet. Here we have the data, and we have cylinder number 3 having 25 misfires. Here's our waveform, so we want to come in and we want to zoom in on this. And we can see that we've got drops along here. So we're dropping on 3. So the firing order is 1, 3, 7, 2, and we're following on each one of these. So 3 is my misfire. We've got 35 out of 25. So it's not a dead miss, but it's pretty close to it. So now that we know what cylinder it is, we need to do a couple of more things. I want to get into the ignition coils and see what's wrong with which ignition coil has a problem. So let's go ahead and connect to the ignition coils. So now let me show you what we've done. We've connected the oscilloscope to the ignition coils. In this case, we've connected channel 1 to cylinder 1, channel 2 to cylinder 2, channel 3 to cylinder 3, and channel 4 to cylinder 4. Now is what we want to do is make sure that we have a good connection. If you notice, there's no red light, and our voltages are all very low. That means that we're connected and we're going to be able to get readings out of these ignition coil secondaries, or the control side. So let's go ahead and start this vehicle up. Now that we have the oscilloscope connected to the ignition coils, we need to get some data. So we want to go over to measure and deep record. We want to start fast capture. Now we're capturing this data. So what we want to do is snap the throttle. Now the most important thing when we do this is you never want to snap the throttle wide open. You'll always get cylinders that will show lean because the fuel delivery has latency. The fuel is heavier than the air, and the air will inrush more into a cylinder and show it's lean. So we only want to snap the throttle about 50%. Let's take a look at our data now. What we want to do is we want to analyze this data that we've taken. This is during our idle period, and this is where we snapped. I want to take the zoom window, and I want to just zoom in here. So we're going to get a zoom, and we're going to see that we have our ignition strikes occurring. So right over here, we have 3 strikes. That's a multi-strike. Multi-strike is mainly for emission or tailpipe purposes, so I got better burn at very low RPM. That usually occurs under 1400 RPM, some cars to 1800. But we can see that we've got multi-strike and it's going, and I can see my burn kick up. So to do this, we can come in a little bit better and we can see that our burns are happening. I want to get my panhand and I want to come across. Notice that right here we've gone to a single fire. We're no longer multi-striking. One of the things I want to note right here is this cylinder has a high kick, which makes it look lean. We want to go through, okay, we've got another one here. So now I want to take that and I want to get my zoom window, and we want to zoom on just these 2. Notice that once I've burned, this negative tail after the burn is very low. Notice that this burn is really big. The negative tail comes way down. That's an indication that the ignition can't continue through the plasma or making the plasma across the spark plug gap. It's ended short, and the ignition coil, being a step-up transformer, has to reabsorb that energy. This negative tail tells me that I have more energy left than I had in this one. And the reason that I have more energy left is because I've got a lean cylinder. Do you see how this is kicking way up high? So this is my burn, and I start and I come way high, and then I couldn't continue the burn to dissipate the energy from the ignition coil, so it had to reabsorb it. This is the reabsorption. This is the high kick. Number 3 has some problem with getting fuel. This cylinder is lean. So now we need to check these injectors to see what's wrong. So all we have to do is move the oscilloscope channels from the ignition coils right over to the injectors, and we can take a look at that. Let's look at what we're going to do. So here's our ignition for number 1. We want to move it to the injector for number 1. And you're going to do the same game with the wires. the odd wire from these units is going to be the control, and that's the one we want to be in. We want to be in the control because we can see what's going on with the control wire. We're going to just go through and we're going to get into all of these units, and then we're going to start the car up and we're going to take a look at these controls. The first thing that I want to do once I've connected is I want to come down and make sure that I don't have a red light. For instance, if I have a red light, that means I'm not in that wire, so I can't get data. So what I want to do is I want to go ahead and we want to get into it, make sure that the lights are out and we have a very low voltage without the key on. If the key is on, and depending on what system we would have, we either have low voltage or we would have a battery power system. Now what we want to do is go ahead and we're going to start the vehicle up. Now that we've connected to the injectors, we need to capture some data to make sure that the injectors are working correctly. So let's do that. We'll go to Deep Record. We're going to go ahead and we're going to get the data so we can record it during our run. We're going to go ahead and stop it. This is our data. Now let's take a closer look at this data. The first thing that we want to do is take the zoom window and we want to zoom in on some of this data. What I want to do first is I want to make sure that the injector for number 3 cylinder, that is the green one, I'm going to put panhand. I want to go back through the data. I can see that that injector is continuously firing. If the driver failed to pull that injector down, we would be lean. I want to make sure that I'm not having any failure of a driver. So we want to make sure that these injectors continually strike. So I'm okay. I'm firing the injector. I'm not having a loss that way. So the next thing I want to do is I want to go where I've got a trigger on. I'm triggering on number 3 cylinder, 20%, 10, 20, that's the 20%. That's my trigger on a falling edge. Now I can see this waveform. Now there's a couple of things that are really important to look at. One of the first things is the tower. Do you see how wide that tower is? With the Zener diode cutting it, the width of that tower tells me how much current is flowing through the winding. In this case, I've got a wide tower with a good cut across the top. This indicates that I absolutely have good current flow through the winding. I have this bump. As I have this fall and the current is going away, the pintle will fall back through the magnetic field and it has an induction. This little hump right there is the inductive kick or the pintle closing. So now I know that I had good current and I have the pintle closing. The next thing I want to do is I want to make sure that as I'm snapping this, that I don't have any failure. I want to make sure that I got an opening, it's opening. So now I can see clearly that the injector is going wider, giving me more fuel. When this turn on or this voltage drops, there's current that starts to flow through this injector. When it shuts off, it goes up, and I have my tower where I cut it back, the flyback voltage with a Zener diode, and I fall. If I want to go ahead and we're going to get some less time here, widen it out a little bit, now I can see that the injector is fully functioning. Electrically, this circuit is working properly. Now is what we need to do is we're going to need to pressure drop each injector to see if one of these injectors, or mainly number 3, has an issue. So let's go ahead and get connected so we can do that. What we're going to do now is we're going to get into the rail system, the fuel pressure. So we're going to take the cap off and we're going to put the adapter hose on. Once we got the adapter hose on, we're going to just use a gauge. You could also use a transducer to do this. Right now we're going to use a gauge. Now it's what we need to do is we need to connect the scope, and the scope is going to control each one of these injectors, and we're going to pull it down using the scope. Let's go ahead and do that. We're going to use the lead that comes in the kit, and we've got two outputs. We've got a TTL, this is an output that sends voltage out, and the pull down out sinks power. So that's the one we want to do. So this will actually sink power up to 20 amps for coils, injectors, and these type of things. Now that we're connected in, let's go ahead and connect it to the car. We're already connected into all the injectors, cylinder 1, cylinder 2, cylinder 3, cylinder 4. We're going to pressure drop each one of these because we're already connected. It's very easy. We're going to disconnect the oscilloscope lead and we're going to connect the pull down out. This will allow the current sink to come through our scope to ground. You're not going to hurt anything as far as a computer or anything goes, but we're going to be able to activate each one of these injectors and then watch the pressure loss on the gauge. Let's go ahead and set the scope up. Now we need to set the oscilloscope up so we can control the injectors. You're going to go to outputs. Right here for the pull down, this is the sink that pulls power down or allows current to go through the scope. And we can set this for any system that we might want to control. So basically for these injectors, I want to set it for 0.3, that's 0.3 of a second, 100 hertz at 30% duty cycle. What we're looking to do is we're looking to have the majority of fuel rail pressure drop. So we drop a good drop. You don't want to drop 5 or 10 pounds. You want to drop 20 pounds or so. If we can drop a lot of pressure, that will be the best way in order to see if one of these injectors has a differential flow rate from the other injectors. The injectors need to be within 1 psi of each other once we test them. So let's go ahead and run the test. Our pressure at rest is 39 psi. Now we're going to activate the injectors with the oscilloscope. Now we're going to watch the pressure drop. So we dropped right about to 23 pounds. So now we need to do the next injector. This is cylinder 2. Again, we have very close to the same pressure at about 22, 23 pounds right there. This is cylinder 3. Our rest pressure again is about 39 psi. This time our pressure didn't drop far enough. We only dropped to about 33 psi. So that one did not drop enough. Now let's check cylinder 4. Now let's flow cylinder number 4. We're about 39 psi. And it's dropping to about 22, 23. So again, we're very close on 4. So now that we've finished the testing sequence on this Crown Vic, what I want to really express, when you're diagnosing a vehicle, you run a test and then you analyze that data. The data set will drive the next test. Then I analyze that data set and it drives the next test. For instance, on this Crown Vic, the very first thing we did is to confirm the misfire was present right now. We started it and ran it. It was. The next logical thing to do is to make sure that we don't have some kind of a pressure issue within one of the cylinders. A relative compression test ruled that out rather quickly. So now that's not a problem. But now I need to know what cylinder is missing. We use the CKP misfire detection software by getting into the crankshaft sensor and then letting the software evaluate my misfire. My misfire said that it was on cylinder 3. So the next step, driven is I need to look at the ignition coil, because by looking at ignition waveforms, we can tell if we have a misfiring cylinder due to not only compression, but whether it's rich, lean, and many other reasons. In this cylinder, it showed that 3 was way too lean, which showed the injector being the problem. Then we moved to the injector, and we checked the injectors electronically to make sure they're being activated and current flow, and the injector has a pintle movement, which we did. The next step, or the next test, would be to flow test each one of these injectors. And that's what we did to flow test 1, 2, 3, and 4. Injector 3 came up with a low flow rating, which is the problem. It shows the number 3 cylinder's injector has some type of restriction, whether it be internally or externally, coking on the tip. We won't know that until we remove the injector. We need to remove the injector and replace it or clean it. That will be up to the shop to do that. The idea is always let your test drive your next diagnostic decision. There is no game plan, guys. It doesn't work. You can't get in the book and follow the trouble tree, and the trouble tree is going to take you to these great places. It's going to take you to the road of ruin. You need to do the test and let that data drive your next test. Always be data driven, and you'll always fix the car in your bay.